Okay? Okay, so the first thing that you got to do is your problem has two terms. That's like really big. You have two terms, and usually, not always, but usually you have like a variable to a third power. That's a real big clue. Okay? The other thing we talked about was we said the perfect cubes go like this. So like 1 is a perfect cubed because it's 1 times 1 times 1. That's what a cube is. It's formed by multiplying a number out 3 times. Okay, what would happen if you did 2 times 2 times 2? In your head, what do you get? 8, not 6, 8, okay. How about 3 times 3 times 3? 27. So we kind of created this list. This list goes on and on forever. If you did 4 times 4 times 4, you would get 64. And then if you did 5 times 5 times 5, you get 125. And so forth. Those numbers keep going on and on and on forever. Okay? So this is a sum of 2 cubes. So what you're going to do on this problem is you're going to apply this formula. And what you have to do first, and this is real important, is that you figure out what A is. Now, A comes from the first term. It is not 125k to the third. It's what you multiply out 3 times that would give you that. So tell me what number you multiply out 3 times that gives you 125. 5. What do you multiply out 3 times that gives k to the third? K. All right, so that's what A is. A is 5k. Now, the reason for that is real simple. Okay, you need to always make sure you did that right. If you multiply that out 3 times, you get what you started with, right? Okay. Now, if we look at B, B is not m to the third. What do you multiply out 3 times that gives you m to the third? Just an m. Good. Okay, so that's m. And then again, if you did m times m times m, you would get m to the third. Does that make sense? Okay. A and B are what you multiply out 3 times to give you what you had in the problem to start with. Now what I want you to do is let's write down this formula, because just for reference. So we're going to go A plus B. This is a sum of 2 cubes. The problem has a sum in it. So we're going to do A plus B, then A squared minus A plus B squared. Once you have A and B, you just plug it in and you're done. Okay, and then I'll probably check this one also. Okay, so here's what we're going to do. You can do this in your head. A is 5k, B is m. Then you're going to do A squared. Well, A is 5k times 5k. Just multiply it by itself. That's how you square something. AB, A is 5k. Okay, B is m. And then when you go to B, multiply that out by itself. I recommend, until you know what you're doing, that you write that out. Okay, eventually you get to a point where you do this in your head. Okay, and that's your goal, is to do this in your head. So let's write the answer then. So what's going to go first is you have 5k plus m, like that. Okay, A plus B. Okay, now what is A squared? What's 5k times 5k? 25k to the second. So be sure when you see that A squared that you multiply the A by itself. Okay, what's 5k times m? Well, 5km. Okay, it doesn't matter what order you put the letters in. You can do mk also. And then when you do B squared, B is m, so m times m is what? M squared. So that right there is your answer to your problem. Okay, that's how you factor a sum or difference of 2 cubes, is you apply the formula. I will end up giving you these formulas, but it's to your advantage to try to memorize these 2 formulas. And I'll talk in a little bit about a couple of strategies for memorizing them, like that. Okay, so that's step 1. So does anybody have a question about anything I did on that problem? Because I do want to check, and then I want to start you off on the next one and see if you can do that. Any questions? Okay, let's check this. It's incredibly important you know how to check stuff. Okay, when you check this, you want to multiply this out. Now let's just kind of carefully multiply this one out together. And let's see if you understand how that goes. We know how to FOIL. This is similar to that. What you do, your first term, you're multiplying those out. So if you take 5 times 25, you're going to get 125. If you do k to the first times k to the second, you get k to the third, because you're adding exponents when you multiply. Okay? Now go to the next thing. Do this thing right there. So 5 times negative 5 is negative 25. Then you have k to the first times k to the first m. So that's k to the second m. Okay, again, you're adding the exponents. K times k is k squared. Okay, then you want to go to this term. So that's 5. It's 2 positives, so it's positive 5. You have a k, and you have an m to the second. Does that make sense to everybody? It's a distributive property. Okay, you got to add exponents when you multiply variables. Now what you're going to do is you're going to do this. So you do this multiplication. So that's 25. That's a positive. So that's 25m(k) squared, or backwards. It doesn't matter what order the variables are in. And then this term, you do that. So that's positive times negative is negative. And then you would have negative 5k. And then m times m is m to the second, like that. Okay? And then the last thing you do is you do m times m squared. Tell me what m times m squared is. M to the third. Good, because you're doing 1 plus 2. Okay? And that's 2 positives. So that would be positive m to the third, like that. Now, if you look at those terms there, do you see anything that looks like it's the same that would just boom, boom, cancel out? How about those? Are those the same? Yeah, they have a k squared. It doesn't matter what order. K squared, m, m. They cancel, and then these right here cancel out. So you want to go ahead and cancel them out. And when you do that, let's see if that takes us to the beginning. Okay, so it looks like we'd be left with 125k to the third plus m to the third. That's the problem that we just got through doing. So we're right. So you have the power to tell you're right on these problems every time, see? Any questions about the checking? Does that look pretty good? Okay. All right, let's kind of go through and figure this one out. I'm going to start you with this one, and then I'll see if you can complete it and check it and everything. So I'll make sure that you can do ones at these levels. Well, one thing you can do on this, when you see 729, you can just multiply backwards. Okay, like on a calculator, you could try like 7 to the third. 7 to the third is 343. Well, that means we found this, okay? All right, so that means that's going to be 7, because 7 times 7 times 7 is 343, so we got that. Let's try something a little bigger. Let's try 9. So if I go 9 times 9 times 9, or just 9 to the third on your calculator, that's 729. So that means A is going to be 9, but it's also going to be a Y, because 9 times 9Y multiplied out 3 times is going to give that. Okay, is that good? So you use your calculator to help you with that. Now what I want you to do is finish the problem. So you might want to go ahead, let's write down the formula. This is a difference of 2 cubes. So the formula is A minus B. Then it's a to the second plus AB plus B the second. Go ahead and plug everything in, get an answer, then I'd like you to check it, because you definitely want to know how to do that. Then we'll move on to ones that have an extra step on them, okay? So see how you do. If you know your formula and you can figure out A and B, then you should be able to do these okay. At least that's the theory. Then you want to take that out, okay? Does this have a common, okay? All right, so what we're going to do on this is, to begin with, we're going to take a 2 out, and then we're just going to have 1 parenthesis like that. Okay, take the 2 out. Okay, now what I'm going to do is I'm going to divide both things by 2. So what goes in the parentheses? U to the third minus 27. 54 divided by 2 is 27. Now, that's a cube. How do you know? You got something to the third, and 27 is a perfect cube, right? Okay, so we've got that taken care of then. So what we have to do now is we need to work on just kind of doing our formula. So over at the side, we're going to kind of look at that being your A and that being your B, like that. So A is what? It's not U to the third. What is it? U. Good. B is not 27. What is it? 3, because 3 times 3 times 3 is 27. You see what I mean? You have to figure that out. Now, what you do is when you write your formula out, is it's going to go like this now, okay? Now, when we do this formula, the formula goes like this. We're going to have A minus B times a to the second plus ab plus b to the second, like that. Okay, start plugging stuff in. Now we are going to have the 2 as a part of our answer. Then we just need to fill in the parentheses like this. Okay, so we do a minus b. So what goes in the first parenthesis? U minus 3, right? Okay. Second parenthesis, you square a. So just do u times u. So what's that? U to the second. Okay, then you do ab. So you're going to do u times 3, which is what? 3u. Okay. Then you do b squared. If b is 3, what's 3 times 3? 9. So there's your answer. Okay. Everybody see how I did that? You take a common factor out first, then you apply your formula. Okay. And then again, what you're doing is you're looking at factoring this with a being u and then b being 3. Plugging in. How's that look? Okay. Now we're going to continue to do some kind of similar things here. Okay, let's look at the next one very carefully. First of all, if you have 64 and 27, you're going to find that the only numbers that go into 64 and 27 are a 1. So you don't have a common factor there. But do you have an x in both positions? Yeah, so what comes out? X or x to the fourth? X. How about a y? Do you have a y in both positions? Yes. So which one comes out? Okay, be sure that you got that down now. If you take out the one with the lowest exponent. So that means your common factor that comes out is just an xy. And again, you got 2 steps. You got that intermediate step, then we'll see if we can complete the factoring. Okay, so what we have here is a 64. You already have an x. What do you multiply y by to change that to y to the fourth? Y to the third, right? 1 plus 3 is 4. Okay, in the second position you need a 27. What do you multiply x by to get x to the fourth? X to the third. Okay, so that is how your first step goes, is like that. Okay, so you guys have been, if you've been doing your homework, then you should probably by now have your common factors down. Is that true? Okay, because if you don't have that down, everything's going to be difficult until you get it down. So here's what we do next. Okay, this xy is a part of your answer. So when we write our answer, we're going to have xy. And then what we're going to do is we're going to use this sum of 2 cubes formula. This is a sum. So the sum formula goes a plus b times a squared minus ab plus b squared. Okay, so that you're going to use that formula. So here's the key. All right, we need to figure out what a is. And we need to figure out what b is. So let's make sure we have that down. Okay, what would a be? What do you multiply out 3 times that gives that? 4y. What would b be? 3x. Good. Okay, you got to do that kind of backwards multiplication. So a is 4y. B is 3x. You know you're right because you multiply it out 3 times. That's what you get. Okay. Now, let's see if we can kind of put this all together now. So we have xy. The first parenthesis, you're just doing a plus b. So that means that's going to be 4y for a. And then plus 3x like that. Okay? So I think you guys have that down. Now see, when you do this second part, this is where students make mistakes, is you're doing a squared. So all you're doing is you're just doing 4y times 4y, which is what? 16y. Good, 16y to the second. Okay? Then you're doing a times b. A is 4y, b is 3x, so what's that? 12xy, good. So that's minus 12xy, like that. And then you're doing b squared. Well, b is 3x, so what's 3x times itself? 9x squared. Okay, so that would be your answer to your problem right there. Okay, so once you take your common factor out, then these last 2 problems were cube problems. They had 2 terms and they had cubes. The biggest clue is the third power. Yes? You got 2 ways to do this. The best way to check this problem is just kind of work backwards through the problem. Just ignore the xy. Multiply all that out. If you multiply all that out, and then you would end up kind of getting there. Okay. And then if you distribute the xy through there, you get this. So all you're really doing, you check, is just kind of going backwards through the problem. But you're a lot better off to multiply that before you work with the xy. Okay, it's easier. Okay. Okay, let's do this next one here. This one's a little different now. So notice you have a 72 and you have a 2. So what's the biggest factor between those two numbers? 2, okay? So let's see, 72 divided by 2 is 36. 2 divided by 2 is 1. So that is the biggest factor we can take out of that. So what you want to do first is go ahead and take a 2 out. And then 72 divided by 2 is 36. And then that would, next term would be x to the fourth, y to the fourth, like that. Okay? Now, let me ask a question on this. See, when you're learning factoring, you got to recognize what you have. How about 36? Is that a perfect cube or is it a perfect square? It's a perfect square. How do you know it's a perfect square? 6 times 6 is 36. How about x to the fourth? Is that a square or a cube? It's a square because it's x to the second times x to the second. Y to the fourth is the same way. Y to the second times y to the second. So this is a difference of 2 squares. So before I finish this, I want to remind you of how easy it is to factor a difference of 2 squares. Let's say you have x squared minus 9. How do you factor that? You have x and x, 3 and 3, and then how did the signs go? Plus and minus. And we talked about that last week. That's how you factor a difference of 2 squares. So this one is going to go like this. You're going to draw 2 parentheses. The first term is 36, so you do 6 and 6. The second term is this perfect square, so that's x squared y squared times itself. How do the signs go? Plus minus. Okay, problem done. Okay, and see, what you have to do is you have to learn that that's a difference of 2 squares. The ones above that were sums and differences of cubes. So you have to differentiate between the sum and the cube. That's how you do that problem. Does that make any sense? So part of it is recognition of the numbers that are cubes and the numbers that are squares. When you have perfect squares, you're looking for numbers like 1, 4, 9, 16. You're looking at even exponents. That's what we learned last time. So that's why that's a difference of 2 squares. Okay? All right, well, let's see if you're catching on here. Let's do a couple of problems. So I'm going to move you to the next. Get it? Okay. I think. Okay. So everybody figured out the xy. That's good. I didn't see anybody have any trouble with the common factors. So that's 8x xy times 8y to the third plus 343 x to the third. So that looked good. Now here's the thing. This right here is a sum of 2 cubes. How do you know? You got third powers. 8 is a cube. 343 is a cube. So you need to figure out what a and b is. So a in this problem is 2y. Okay, b in this problem is 7x. Everybody understand that? Now you got to probably use your calculator until you get a little bit better skill with these numbers. So now what we do is we follow the formula. So you have xy. And again, this is what I see when students learn this. They don't have any problem with this first step because that's just 2y plus 7x. Okay, so you have that. Now, here's where it goes wrong, and this is what you got to work on. Now, what are you doing? You're doing a squared. Well, what happens if you do 2y and square it? What do you get?
4y squared.
4y to the second. That's where a lot of you are still messing up. Okay, then you do ab. Well, what's a? A is 2y. B is 7x, so what's that?
14xy.
Okay, and it's a minus because the formula tells you that. So that's minus 14xy. Just try to learn to put things in alphabetical order. That's the best way, okay? Then the last thing is the b squared. So what's b? B is 7x. What's 7x times 7x? So that's where most of you are messing up, is that second parenthesis, so that's your answer. Okay? All right? Do a squared, ab, b squared. Okay? You're following the directions of the formula. All right. Is that getting better? Yes.
For this 4y squared minus the 14xy. I'm not sure what happened.
That's coming from this second part of the formula. right here. Okay, so what I'm doing again on this is we figured out a is 2y, so what are we doing? We're doing 2y squared, really, which, what does that mean? 2y times 2y, which is 4y the second.
Okay, but how did you get to the 2y from the a and b?
Okay, because you need to look at this part right here. Go back here. See, after you took the common factor out, this is a sum of two cubes. So where did the 2y come from? What do you multiply out 3 times that gives you 8y the third? 2y. 2y times 2y times 2y is 8y the third. That's how I figured that out. And then the b is what do you multiply out 3 times that gives 343x to the third? That's 7x. So if you do 7 times 7 times 7, you get 343. So once you take out the common factor, that's a part of your answer. The xy is a part of your answer, but then your total focus becomes, I need to factor that. And that's the formula. And then a and b is the first thing you've got to do before you use the formula. Okay, does that make sense?
Yeah.
Okay, all right. Okay, what was the common factor on number 25? 3, okay. And there's a c also. There's a c to the first and a c to the fourth, so you should take a 3c out. Okay, and you can do this however you want to. If you're comfortable doing this in your head, that's fine with me. That's just going to give you c to the third, because 3c times c to the third is 3c to the fourth. And then 81 divided by 3 is 27. The c's are going to cross out, leaving you a d to the third. So that's step 1. Step 2 is you have to recognize that I have a difference of 2 cubes. Is that logical to everybody? How do you know? You got third powers. And 27 is a cube. How come? Because 3 times 3 times 3 is 27. So what you're doing now is A would be what in this problem? C. What would B be? 3D. Everybody got that? Okay. Now, when you write your answer, it goes like this. You're going to follow this formula precisely. So you have 3C. When you do A minus B, that's just C minus 3D. Okay, now here's the place where you got to be so careful. Do A squared. C times C, what's that? C squared. Then you do AB. Okay, what's A? A is C, B is 3D, so what's that? 3CD. Okay, and then you do B squared. B is 3D, so what's 3D times 3D? 9D to the second. So there's your answer. Okay. So work on that second parenthesis. That's what a lot of you aren't doing right. Okay, but you'll get it once you kind of get the hang of it. Okay? All right, tell me if that makes any sense. Okay? Yes?
So B would be negative 3D?
You follow exactly what the formula tells you to do. In A and B, you don't ever want to use negatives. Because when you're figuring out these signs, you just follow that from the formula. If it's a difference of 2 cubes, you're going to have a minus there and everything else is plus. If it's a sum, you're going to have a minus there and everything else is a plus, like that, okay? So you don't ever want A and B to be negative numbers. You want to just follow the formula. Does that make sense? Okay, the formula will tell you what those are then. Okay, now let's take a look at this one then, okay? Now these are very easy problems to do. They kind of look weird to students, but let's pretend like instead that you had this problem. Let's just suppose that I gave you that problem, okay? What kind of factoring problem is x squared minus 49? It's a difference of 2 squares, right? 49 is 7 times 7. That's a square. X squared is x times x. That's a square. So if you were doing this, the way that you do this is just kind of backwards foiled. You have x and x, 7 times 7 to get 49, and then how did the signs go? Plus minus, right? And the reason for that is because the inner and outer have to cancel. If you foiled that out, you would have x squared minus 49, but then the inner and outer cancel, right? So this problem right here is the same thing. It looks a little different, but it's still a difference of 2 squares. So let me show you what I want you to do on this one then. Okay, so when we do this, I'm going to erase this because that was just kind of trying to get you to see the pattern. What we're going to do is this is the first term. That's the last term. And then this time what I'm going to have you do is draw 2 brackets instead of parentheses like this. Okay? It's basically the same thing. Okay, what would you multiply together to get x minus 2 to the second? Exactly, x minus 2. So you would just have, instead of x and x, you would have x minus 2, right? Okay. What would you use for the 49? 7 and 7. Okay. And then how did the signs go? Plus minus. It's the same thing. You see what I'm talking about? Okay. It's just the first term, the last term, plus minus. Now, we're not done with the problem, because if you look here, does this have any like terms? Yeah, negative 2 plus 7 is what? 5, right? So that would be x plus 5. That's how that goes. Okay? Look at this right here. Does this have like terms? Yeah, 2 and 7. What's negative 2 minus 7? Negative 9. Good. Okay, so that's going to be x minus 9. There's your factored answer. You don't really need the brackets. So the final answer, and it doesn't matter which order these are in, you just have x plus 5, x minus 9. It's the same thing. What you need to see, and a lot of times students don't see this, is if you had like y squared minus 49, well, what would you do? You would go y, 7, 7, plus minus. Didn't I just do the same thing? Yeah, okay, instead of the first term was x minus 2, x minus 2. It was a whole thing. Okay, does that make any sense? Yeah. It would be kind of hard to check this one, although you can look at this. I mean, the thing is, just look at the first term. What's this times this? Isn't that just that? Anything times itself is something squared, right? And then what's 7 times negative 7? Negative 49. And what happens is this inner term, see how they're the same? That's 7 times this. That's minus 7 times that. They cancel. Does that make any sense? Now that's one way to do that. The other way you could check this is you could multiply the whole problem out, and then you could FOIL your answer, and they'd be the same. You could do that either way. Okay? Okay, I want to see if you guys can figure this one out. Okay, just do the same thing. And we're going to work a little bit on perfect square trinomials to wrap this up. There ain't going to be much you can do on this one either. Okay, all right. All right, so what are you going to use for the first term? There you go. 9x plus y, 9x plus y. Very good. What are you going to use for the last term? 4. 4 times 4. How do the signs go separating those? Okay. That's it. Now, are there any like terms inside the brackets? No. So that means the answer could just be written as 9x plus y plus 4. You want to write it that way. You don't need the brackets. I just like to show it that way because you kind of have parentheses within brackets. And then this would be 9x plus y minus 4. So that's kind of a different looking kind of problem to what we've seen. It's the same principle. Okay. All right. Does that look all right? Okay. Just an extension of the idea. Okay, next thing we're going to look at is perfect square trinomials. Usually on these, I just teach these in the same way that I've taught trinomials anyway. So I want to show you a couple of things on this. There's a couple of patterns. I want you to just write these two problems down because my goal on here, first of all, is to teach you kind of how to spot when this happens. Now, these are trinomials. And first of all, if you look at this first term, that's a perfect square. It's x times x, right? This last term is also a perfect square. It's 3 times 3. Okay? Now, the thing that makes this a perfect square trinomial is this thing. So, if you double the 3, what do you get? What's double a 3? A 6. That is the structure of a special kind of factoring problem we call a perfect square trinomial. And what you want to learn how to recognize is the first term is a perfect square, the last term is a perfect square, and then if you take these two things, like the x and the 3, which is 3x, and you double it, and you're going to get that middle term. Okay, that's how these things work. Okay, let's look at this next one. It's a little bit more complicated, but it's the same idea. Okay, what would you multiply by itself that would give you 4y the second? 2y and 2y, right? That's a perfect square. What would you multiply by itself that would give you 25? 5 times 5. That's also a perfect square. Okay, now, take this and this, just multiply one of those together. So if you do 2y times 5, that's 10y, right? What happens if you double a 10y? You get that. Okay, that's the structure of what we call, this is a special trinomial that's called a perfect square trinomial. Okay, at a minimum, what you guys need to at least recognize is the first and last term are perfect squares. If you recognize that, then you're going to be okay. Okay, for now anyway. Okay, all right. So let's go through and do some of these. Now this is just depends totally on how good your skill is now with trinomials. Okay, all right. Is the first term a perfect square? Is the last term a perfect square? Okay, so that's what you have to recognize. Now, what you're going to do is you're going to draw 2 parentheses. These are also very easy to factor. So your first term, you're going to have x and x. To get an 81, you're going to have a 9 and a 9, right? Now, the way I taught you trinomials is just kind of like this. That inner term is 9x. That outer term's 9x. What are you wanting those to add up to? Okay, so you double a 9x to get an 18x. So that means the signs are going to go like that, right? So that means you're going to have a plus plus. So that would be one way to write the answer, is it's just x plus 9, x plus 9. What's another way you could write the answer? If you have something, the same thing twice, how do you write it? Something to the second. Good. Okay, so the way you typically write your answer is x plus 9 to the second. Okay, like that. Okay? And that's the way a perfect square trinomial is going to factor, is it should just be something squared. Like that. It'll always be the same. Okay? All right, let's look at this one. Is that a perfect square, 9x squared? Yeah, that's 3x times 3x. How about 4? 2 times 2. So if you spot that, that's at least helpful. Okay, now we're going to draw our 2 parentheses. And we're going to do 3x times 3x and 2 times 2. Okay, now let's just see if we'll get this to work out. So that inner term is 6x. That outer term is also 6x. What do you want that to add up to? Okay, is that something that you can manage? Yeah, how do the signs go? Minus, minus, okay? You know negative 6 minus 6 is negative 12, so you'd have that. So see, notice it's the same factor twice. So that means you could write your answer as 3x minus 2 to the second. Okay? That's the idea. That's not too bad. If you got your trinomials down, then that shouldn't be that bad to you. Okay? Okay, let's look at this one, and I'll let you do a few problems to finish this up here. Okay, first term is a perfect square. Last term is also a perfect square because it's 5y times 5y. Okay? And then if you double 5y, doubling it gives you the 10. So what you would do with this one is, same idea. You put an x and an x there. You put a 5y and a 5y there. And the inner term is 5xy. The outer term is 5 times xy. So how do you make that add up to negative 10xy? It's both negative, right? Okay, that's your middle term. So you're going to get 5 and 5 to add up to negative 10 if they're both negative. So see, it's the same factor repeated. So you just write the answer as x minus 5y the second like that. Okay? Isn't that slick? Kinda. Okay. It's a special kind of problem. We do this like, I see this a lot when I was teaching Calc 2 this morning. I seemed like that showed up a couple of times. Just kind of a piece of a bigger problem. Okay, so let's do the next 2. I'll give you a few minutes to do that. Then I'm going to go ahead and finish up. I'll just show you how to do the last 2. on here. So this one, really all you should have to do is just draw your two parentheses and see if you can get that put together right. And you can check these by FOIL, so they're all checkable. All these things are. Let's see if we're on the right track here. Okay, why don't you catch on? There's nothing to it. Okay, so this one you would have x and x. 12 times 12 is 144. If you don't know that, you just take your calculator and take the square root of 144 and it gives you 12. So how do the signs have to go on this one? Yeah, two pluses, because you're trying to get a plus 24x. Two pluses. Okay, so that means the answer that you would have is x plus 12 to the second. So you write it like that. It's a perfect square trinomial. Okay. All right, the next one, you have 64. So you should have done 8x and 8x. For the 9, you should have done 3 and 3. Okay, this middle term is 24x. That outer term is also 24x. So how did your signs go on this one? Two pluses also, right? So you know 24 and 24 adds up to 48. So you do have the same factor twice. So you just write that answer as 8x plus 3 to the second like that. Okay? So it's pretty easy to spot, particularly if you spot the first and last term, then there's a chance it's a perfect square trinomial. Okay? All right, let's go to this last thing. I'm going to do a problem and let's try to do one, and then I'll close this off on this. Okay, one of the things we learned is this is not always the truth, but often if you have 4 terms, the strategy you use is factor by grouping. And we've learned how to do factor by grouping, but we just have never seen a factor by grouping that looks like this one. Okay? So you have to group this together a certain way. What you've typically done is I've typically had you group the first and last together. If you did this on this problem, it wouldn't get you anywhere. But I want you to look at the first 3 terms. Does that look like anything that you've learned anything about? Yeah, like you just learned it, right? Okay, so that's something we can factor. So actually what we're going to do is we're going to put together the first 3 like this. Then we're just going to bring down the y squared. Okay, so we're going to factor that. See, this is a trinomial, so we're going to focus on factoring that trinomial. And that's just like the problems we just got through doing. So I'm going to draw 2 parentheses, again, just bringing the y squared down. So your first term, you're going to use x times x to get x squared. What are you going to use for the 9? 3 and 3. Good. Okay. Now you can do the signs in your head. If you need to do this visual, then please do it. So 3x and 3x, how do you make that add up to negative 6x? 2 minuses, right? Okay. So what you're going to do next is you're going to write this, since that's a perfect square trinomial, you write this as x minus 3 to the second minus y to the second. Now this is a problem I also showed you how to do today. I don't know if you recognize it or not, but what you would do on this one is a difference of 2 squares. So the first term is x minus 3 squared, so that would go like this. You would just say x minus 3 to get that, right? Okay. And then that's the first term. So it's a whole quantity, x minus 3. What are you going to use for the y squared? Y times y. And then how do the signs go in the middle of those 2 things? Plus and minus. There you go. We did that earlier. Okay, you may have already forgotten, I don't know, but that's kind of the idea, is factor by grouping this way. And then the final answer would be x minus 3 plus y times x minus 3 minus y, like that. Okay, and that's your answer. I am going to check this one just because it's different. And then I'll let you just finish up with the last one here. So that's it. Does that make any sense, what I did? Okay, you got to recognize the first 3 terms are a trinomial. and then it turns into a difference of 2 squares. Well, let's write down the checking. We actually haven't multiplied anything out like this yet, so let's take the time to do that. So actually what I do is I got to multiply the x by everything to start with. So I just go x times x is x to the second. Then I do x times negative 3 is negative 3x. Then I do x times negative y is negative xy. So what I'm doing is I'm doing a distributive property 3 times. What I just got through doing was the x times everything. Now I need to do the 3 times everything. So I've got negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Negative 3 times negative y is positive 3y. There's 6 multiplications. Now I got to close off by doing the y times everything. So I have y times x. That's plus xy. Negative 3 times y is negative 3y. And then y times y is negative y the second. So what I'm doing on that is just taking x times everything, 3 times everything, y times everything. So there's 9 multiplications. Does that look okay? It's a distributive property. It's just a bunch of terms. Okay, now let's see what we have on there. Probably got some things that'll cancel. Those cancel. The 3y's cancel. And it looks like what you're left with is you're going to have an x squared. These go together. That's minus 6x. Those don't cancel. Plus 9 minus y squared. Is that right? Does it match the original problem we just did? It definitely does. So see, that matches that, so it's right. Okay, so you can tell you're right. You have the ability to do that. Okay. All right, well, let's go ahead and do this one. I'll let you guys do this. And we'll do a break. So group this together this way. Then do your 2 parentheses for the trinomial, and then see if you can get that one put together okay. And let's see if you at least got the answer here. I'm not going to take the time though. Okay, so let's see. For 49, what you should have done is you should have used 7x and 7x. For the 25, you should have used a 5 and 5. Okay, and then how did the signs go on this one? Plus plus. See, they're both 35x, and you're trying to make that add to 70, so it's plus plus like that. Okay, so that means you should really rewrite this as 7x plus 5 to the second minus e squared. And you got to realize that's a difference of 2 squares. There's a difference in the middle of 2 perfect squares, and you can draw 2 brackets or you can even draw 2 parentheses. It doesn't matter. Okay, so what do you multiply by itself that would give you 7x plus 5 to the second? 7x plus 5, 7x plus 5. So you want to have that in there. Okay, and how about the z squared? Z, how do the signs go? Problem done. That's it. Okay, that's not too hard. What do you think? You got to learn how to recognize this stuff. That's key. And then you can multiply that out if you want to, and it will check. Okay.